Hello, experimental meth people. This is our circuit. We have built an audio booster, and we will teach you how to do this today as well. My associate Chad Long here will demo it for you.
This is loud. This is soft. Being controlled by a potentiometer, aka a resistor that changes value based on your manipulation.
First we'll explain some theory. Basically, our circuit consists of two inverting op amps, which, because your first current is inverted, and then needs to be re-inverted in order for you to get the sound the way you want it. So, we'll start out with an op amp with a gain of 1. So here's your op amp. You just ground the positive terminal. And then in order to get a gain of 1, you have to have a ratio of RF over RI equal to 1, which is your gain. So we'll put a 1 k ohm resistor right here. And then connect that to the output. Put a 1 k ohm resistor here. And this is our RF. And this is our RI. And then we're going to have a voltage of 4.5 going into the terminal. Now this will get us a negative voltage input with a gain, or a negative current input with a gain of 1. So in order to fix that, we're going to have to use another inverting op amp with a gain factor of 10 because we want to be able to boost our audio by a factor of 10. And we know our potentiometer has a max resistance of 50 k ohms. So if we take our RF over RI and we use our potentiometer as our RF, we have 50k over X equal to 10. And of course, X is equal to 5 k ohms. So, we'll have our RI equal to 5 k ohms. And our op amp again. Ground the positive terminal. And then have our feedback resistor, which is our potentiometer, which has a max current of 50 k ohms. And right here is our V out.
Now we're going to go over how to use op amps as part of your integrated circuit on your breadboard. And we'll go over a little bit of theory involved with that. So for the purpose of the previous theory, we used a constant voltage, when in actuality we're going to use a voltage from our audio, which will be a song played from a device instead of the 4.5 volts. And now, how an op amp works is it's powered by a V positive and a V negative, and then your two inputs and a V out. The other three pins we did not cover during the course of this project. And so, as seen here, you'll have a V positive and a V negative that power the op amp for both. And then when looking down on an integrated circuit for an op amp, you're looking at 8 pins. And so the V out, which would be equivalent to right here, will be pin 1. Your negative input, which would be equivalent to right here, would be pin 2. Your positive input, that will be ground, will be equivalent to pin 3. And then your negative and your positive, the values can be changed, will be at V4 and 5 respectively.
Now we will go into the design process. Here's everything you'll need. You'll need wires, two 1458D op amps, a 5 k ohm resistor, two 1 k ohm resistors, a potentiometer, and input and output audio cables.
Alright, so after you pick out your op amps, which will look like this, you'll place them on the board, and you have to make sure you place them across these little, basically like canyons in the breadboard, so that the legs don't circuit each other, because you can't put them any other way, as if you put them like this, or like this, because otherwise the way the breadboard works, it'll be short-circuited, because all these are horizontal rows. And so what you also need to do is make sure you have power for your breadboard. And so by connecting the red, which will be your positive input, you connect it along this little column, and it runs along the entire breadboard. And the same goes for the negative, which is yellow, and the ground, which is black. And so the first thing we'll start out with is we'll just go from left to right along the schematic. And so you have your input here, which is going to be like your MP3 player. And so what you'll do is the initial input will be going into this second op amp. However, you see that you do need the 1K ohm resistor there already, and so we're going to drop the 1K ohm resistor, and then we're going to stretch it across the board just for ease of viewing. And so you'll put the resistor right here, and then you'll have this wire. Actually, we don't need this wire. We can just directly put the input cable right here. And so you see the white wire, for our purposes, we will not use. The black wire goes to ground, and the red wire is the input. And so you put it in the same row as the resistor. And then you put this row into the black column, which would be the far right. And so this is now grounded, and we now have an input. And so it goes across that 1K ohm resistor into the V negative input. And then you'll see the V positive and V negative have been marked, as well as the ground, and so right now we will complete that process. The V positive is on the pin number 5, and the V negative is on pin number 4, and the ground is on pin number 3. And so we will note ground by black, and so we go to pin number 3, and we go back to the black column that we used earlier for the input ground. And then we will use red to denote positive, and so positive goes into pin number 5, which goes to the positive rail, which is the one on the left for our operational purposes. And then we have to do the ground. Actually, we already did the ground. Rather, we need to do the negative input, which is going to be yellow. And the negative goes to the 4th pin on the left, or pin number 4, and that goes to the middle, or the negative rail that runs all the way down the board. And so we've set up the op amp so far, and now we just need to put the feedback resistor in. And for the first feedback resistor, it's 1 kilo ohm. And so you go from the V out to actually the same row as the 1K ohm resistor is in. And so it's a really short hop, and you just kind of bend the resistor out and pop it in. And we're going to move over the 1K ohm resistor just to make it easier on us. Like so. And then the last thing we need to do is do a V out, which we're going to denote by green. And so we take from the same resistor, or the same row as the first leg of the feedback resistor, and we hop it back or we hop it over to the second op amp into its V in, which is the second row. And then from there we're going to repeat the process of the V positive, the V negative, and the ground, and we'll do that later.
Alright, we just got done doing the first part of our schematic with the first op amp here. So we're going to now complete the second part of the second op amp, which has the gain factor of 10, which will increase the volume. So we're going to take a green wire, and we're going to run it from the output of this op amp to the input of this op amp. So we take our wire, and we go to pin 1 of the first op amp. And just run it to a random place in the board that's not on the rails. You then take your 5 k ohm resistor, and you run it on the same rail as that green wire into the input of the second op amp, which is pin 2. Okay. Now what I did during the break was I also added the positive and negative voltages, just like the last one. Nothing special to it. Okay. Now we're going to have to ground the second input, which you take your wire and you go into pin 3, and then you just run it over to your ground rail. Okay, so now we're done this. Now we have to integrate our feedback resistor, which is our potentiometer. Now the feedback resistor goes from the input to the output in parallel. So you take one end and you go into pin 1, which is your V out. Back to where you put that 5 kilo ohm resistor, which is in pin 2. Just like so. And now we're going to get to our output. So we're going to take the red wire and black wire, and just as before, the black wire goes to ground. And the red wire will go to pin 1 with where the output is. And there you have it. All you have to do is plug this side into any audio source and have any kind of speaker or headphones in this side, and plug your breadboard in and you'll have a speaker with an amplifier. Thanks and have a wonderful day.